Good evening, everyone. Welcome to the last problem solving section on industrial wastewater treatment. We are familiar that he is our course instructor, and my name is Manyatnam Prakash, and I am from IIT Kanpur. This is the last meeting and the recording of the all session from week 1 to week 12 can be found on this YouTube channel. Okay, so at the end of the session, I will share you the link. So if anyone have any kind of doubt, he or she can go and check it out. Okay, now. So in week 12, we were looking at this last topic that is about mine industry. Okay, na. So whatever the wastewater is coming from the mine, and the topic which was said that mine wastewater including acid mine drainage and industrial complexes for zero pollution attainment. Okay, na. So somehow overall, if you have gone through the lecture, you will be seeing that they were talking about this mine industry. Okay, na. So here also, like previously in whatever industry, different industry we have seen, like textile or steel industry or tannery industry. Everywhere we see that some kind of wastewater is being generated due to utilization of water. Okay, now so here also in mine industry also there is some production of wastewater, and how those wastewater is being treated will be discussed here. Okay, so if there is a small recap of whatever was taught in the class. If anyone have any kind of doubt, he you may ask in chat box. Chat box is always open, or you can also unmute yourself and you can say anything if you want. Just 1 minute. Is my recording going on? Yes, recording is on. Hmm. So remember, this is some of the brief introduction, like coal mining overview. India has around this much billion of ton of coals reserve. But itna billion ton proven 80% of coal is extracted by open cast mining, primarily used for power sector. Major coal producing in India, Odisha is the highest one, then followed by Chhattisgarh, then Jharkhand, and finally Madhya Pradesh. Okay, now so there is a big misconception that in Jharkhand there is too much coal, but you can see that only 17% of the coal is produced from Jharkhand. Most of the coal is produced from Odisha, that is around 24%. Okay, then these are different type of coal, and how this type of coal is produced based on the carbon content. Okay, now so how much carbon is there in our system, in our coal, based on those things these different type of coal type is recommended. Okay. Hmm. So generation. Then we have this water generation. Mine water is a surface or groundwater from the mining operation collected in a pit and pumped out. It can be contaminated by leaching of the waste piles, introducing sediment, acidity. So see what happened. So like I was going through some internet and all these things. So what happened that during mine generation, to like we know that they dig up under the water and dig up underground and all these things. So to when there is too much temperature and all these things, so to cool down, and too much dust also, to suppress all these dust and to cool down the surrounding and all these things, they use a huge amount of water. And those water is somehow passed from one place to another place. So what happened that the soil which is there, contains so much of contaminant, maybe some hazardous material also, and all this thing. So what happened that those contaminants gets mixed in this water, and we get this wastewater. Okay now, so that is called mine water generator. Okay now, so we have to treat those kind of water before dumping it into openly into in maybe river or anywhere. Okay, so what is the key characteristics of mine water? It is alkaline, having pH between 6.5 to 8.5. It is high alkalinity, means high carbonate is there. Why high carbonate is there? Because in our soil we know that we have something called calcite, CaCO3. Okay, so what happened then when this water is passed through the soil? Some of the carbonate dissolve. Okay, carbonate dissolve, and this makes our water highly alkaline, hard, because we have calcium, magnesium in our soil. Then high TDS is also there. TDS can be ranging from 3,300 to 2,500, because so much minerals are present there, and some of them might leach out. BOD and COD is present, means some organic, we know that in our soil some organic matter is present. Okay now, so some BOD and some COD is also there, but it's there, it's not like that there is no COD, no BOD. Due to presence of organic matter, there is some COD and BOD also. Okay, then we have something called acid water, that have pH of 2.5 to 5. Okay now, so you can see that this is ready mud, like due to presence of high minerals and all these things, some like concentrated water you can say, that has a pH of around 2.5. Okay now, so here due to presence of these minerals, the water has somehow converted into more acidic, and you can see from the pH is between 2 to 5, and it is very highly acidic. So there is two kind of alkaline water is there, and then there is a acidic water. Okay now, so in mine water we have these both kind of things. Okay, so what is the this AMD chemistry? That is, you can see that different. You can see that each oxidation, like initially we have iron 2 plus, and it has uh, see here the iron is add as it is, but here you can see about this H2. Okay now, here sulfur. Sorry. Um, you can see that through oxidation there is an increase in H plus concentration, and we know that pH is defined as minus of log of H plus concentration. So if H plus is increasing, so eventually pH will decrease. Okay now, so making it more acidic. So you can see that all these process, whether this process of Fe plus sulfide, okay now, is making our water more acidic. The through all this reaction, that is initial oxidation, then rate determining steps, then hydrolysis and cyclic acid generation, you can see at the end of each reaction there is a huge amount of H plus being released. Due to presence of high H plus, there is too much acid, and our water is acidic in nature. Okay, these are some of the bacteria which is responsible for either supporting and or you can see bacteria like this accelerate pyrite oxidation worsening AMD. Okay, AMD composition, typically coal mine AMD has a pH of this much. This iron is this concentration, magnesium is of this concentration, sulfate, and these concentration are very high. Okay, now in all over India we can find uranium and all these things also. So these were some of the uh, hmm. Okay, so these are some of the concern that it will contaminate our groundwater pH. The suppose if this acid mine water somehow go into the groundwater, so what will happen that our pH is normal pH is 7. So due to presence of high H plus, the pH will go below 7, and it will make more acidic. Okay, so that is not good for our groundwater, because it will contaminate. Eventually we are pumping out those groundwater only. So we have to treat it. Lower the pH. Deposit of yellow by boy, that is ferric hydroxide. This ferric hydroxide is in yellow in nature. Okay. High metal concentration, effective acidic water is harmful for drinking, kill aquatic life, and all these things. So, what are the different treatment technology? Acid mine treatment, coagulation is there. Then filtration is there. Then some other use of limestone is there, and the process involved some reaction. Whatever the reactions are involved is written in your lecture note. Okay, now so this is just short notes, but how this cleaning is process is done, you could always refer your class notes. Then we have something called uh, sorry huh. Then we have this AMD treatment also, that is acid mine drainage treatment. These are some of the process. I am not going into this thing. We have in situ, like directly we are treating it. Then we have pump and treat method also. Okay, now where we use limestone and all the thing in situ. What we some of the like we are like we know that our water is acidic in nature. So if we have acid, then we can neutralize it by adding base or alkaline. So that's why alkaline injection in mine site. It's low energy, minimum reagent, low maintenance, but it is very slow and large amount of acid base is required. Okay. Then to treat this industry, we have something called industrial complexing or common effluent treatment plant, CETP. Okay, now so there is one something called STP. Then we have CETP. Does anyone know what is STP and CETP? What is STP? What is STP and CETP?
Sewage treatment plant.
Yes, yes, correct. So what happened that for our domestic purpose, like domestic sewage, whatever they go, they'd go directly to our STP, and there is such treatment and all these things. But in industrial area, for example, in our Kanpur, we have STP, but that has a smaller MLD value. Okay, na. But but as we know that we have tannery industry here, and a huge amount of chromium or industrial waste is being generated. So to treat a specific kind of this wastewater, these water are passed through the CETP. What happened that here, common effluent, like common, we are saying that because here this industrial will be also coming, domestic will be also coming, this water will be mixed up, and then it will be going into the CTP, and it will be being treated. Okay, now so CTP only STP only domestic, CTP combination of many things. That's why it is known as common effluent treatment plant. But treatment process is same as means there might be some difference also, but overview is same thing. Okay. Centralized facility to treat effluent from multiple industries, similar to municipal sewage treatment. Okay, now so here you can see that suppose there are several industry, some household is there, so they all will be going into this treatment plant, which will be known as CTP. Okay, now again it has same thing to do, that we it has to reduce the environmental norms. PH should be DOD, COD, TSS, TDS, and all these things should be within the limit as per prescribed by pollution control board. Okay, na. CPCB. Okay. Objective is to cost the combining effluent, enable metal. These are some of the advantage and all these things. Okay. Then process is similar process. Primary function is there to remove the larger, then secondary, then we have tertiary, BOD removal, COD removal. Then industrial specific is also there. Okay, now complex organic chemicals, power plants, iron and steel, pulp, and we have seen. So like for see, for chromium treatment in Kanpur, they use something. They use the concept of membrane. Okay, na. Although the efficiency is very low, so they are shifting to new CETP. but currently CTP which is running, they work on the basis of this membrane system. Okay, now where this they remove chromium and all this thing. Okay, so this was all about a brief recap. Anyone have any doubt till now? I hope everyone has gone through the lecture. Anyone have any doubt? No, then as usual, I will be going through some questions, and I request everyone to please participate uh, by writing your answers in chat box. Uh, yeah, that's all. So this is the first question. What is industrial complexing? Complexing, sorry, not complexing. What is industrial complexing? Anyone? B. Collaboration among industry to exchange resources. Okay. B. We got one answer. B. Yes, the correct answer is B. Collaboration among the industry to exchange resources. Okay. Industrially complexing refers to the strategy clustering of industry. Example: cement, fertilizer, pulp. So this is like simple thing. Like we have A industry, B industry, C industry. So there will be some byproduct. There will be original product of this industry, and there will be some byproduct, and this byproduct will be used as a raw material for industrial B, and similarly for the raw material for this industry will be used for raw material most common example is sugar cane industry, sugar industry, and paper making industry. Okay, now so what happened that the pulp which is generated here is used as raw material for paper industry and so on. Here you can see cement, fertilizer, sugar, pulp, and paper to share resources and byproduct and waste streams. So for one industry it may be waste, but for other industry it may be raw material. But if they started to sharing this thing, there will be a mutual benefit for both of the industry. For example, one industry like fly ash from the power plant can be used as raw material for cement production. We know that in power plant a huge amount of fly ash is generated because of burning of coal. Okay, and this can be used as a power. This as the whatever the burned material is there can be used as a raw material for cement production. Another minimizing and treatment costs. The collaborative approach enhances the sustainability and often involves shared infrastructure such as CETP to manage the wastewater collectively. So other option are incorrect. This is there is no competition. We are complexing means we are just okay now. Industrial pollution is another thing. Industrial waste management is not related directly related to the seed complexing. Okay now, it's like they are managing industrial wastewater because see they are for industry and they are sharing the raw material. But if but they have a common CETP. So somehow they are managing this, but it is not directly related to industrial complex. It is a part of industrial complexing. Okay, I hope this is correct. So correct answer was B. Which of the following is not a benefit of industrial complexing? Not benefit. They are asking not benefit. You can just see, yes, we know that if raw material is being shared, there will be cost cutting. Obviously, ABC is there. So waste of A is being used in B, waste of B is being using C, waste of C is being used in A or B. So you can see that uh, uh, this thing is also a beneficial thing. Enhance resource efficiency. Obviously we are not depending upon the outside resource, we are depending upon each other. So this is also a benefit part. But you can see that there is confusing. Okay, no, you don't have to get confused. Thing is simple. We have some industry A. For example, sugar industry is there, and there is one paper industry. So how sugar is produced? Sugar is produced by crushing the sugar cane. So from the sugar cane they extract the sugar. What do I say? Sugar juice. They extract the sugar part, and there the wooden part, which is there. It can be like kept as a waste. But suppose this industry is nearby this paper industry, which need wood. Okay, now so this waste which was generated here can be passed through this to this paper industry. Okay, now so like they are like now this paper industry is not relying on any outside source, any outside resource. Alternative C also benefits. No, it's not increased competition among. They are not competing with each other. How they are competing? They are not competing with each other among.
Sorry, can I speak?
Yeah, yeah, yeah.
Because if CETP is applied in a given organization in a given industry,
Hmm.
then the cost that is for waste management will be decreased. Yeah. So if this so, then the competition or getting more profit will be increased. It is in my thinking also.
No, you don't have to think like this. We are see. Uh, like we are talking about the increased competition among industry. How miss this? Like now, suppose there is A industry and B industry. Okay, na they are benefiting each other. They are not competing with each other. Miss like competition will be when there will be competition. Like competition will be they are first they are asking about industrial complexing. So you don't have to compare with any industry X by Z which is outside this industrial complexing. Okay, na in industrial complexing, suppose there is a ABC industry. Three industries are there. Are they competing with each other, or they are mutually benefiting each other? They are
Okay, sir. Okay, understand. Okay.
they see they are talking about this. They are not talking about any other whatever. Suppose there is one event happen, and suppose three industry come up together to, and we call them as a industrial complexing. Okay, now so are these three industry competing with each other? No, they are benefiting from each other. The raw material from the waste material from one industry is being utilized as a raw material for another industry. For example, this power plant and cement industry. Are they competing with each other? No. They might be competing with another cement industry, but that cement industry is not part of this industrial complexing. These two are just part of industrial complexing. Did you get it? Okay. So the correct answer is C. Hmm. So the correct answer is increased competition among industrial complexity involve collaboration among industry to share resource, byproduct, and infrastructure such as CTP to optimize the cost saving. That benefits include cost saving, reduction in waste generation, cost sharing because shared treatment facility reduce the individual cost. Okay, now remember there is A industry. Suppose A has to go build their own CETP, B has to build their own CETP. So there will be some external. Now they are both are saying same thing. So there will be cost cutting, reduction in waste generated. I say that raw waste of this may be used as a raw material for this industry. Example one become another raw material, and enhanced resource recovery, recycling water within the complex. However, increased compression is not benefit as complexing for foster cooperation, not to library to achieve the mutual gains. We are mutually benefiting each other. I don't want two cement industry. Two cement industry can never be doing industrial complexing. Okay, na? Either it will be paper, sugar, cement, power plant, like this. Okay, na? Why other option are incorrect? In this thing we have said. Okay, na? So the correct answer is C. Increase competition among industries. Question number 3. Industrial complexing promotes. It is asking about promotion. A. Yes. Circular economic principle. Correct. The correct answer is circular economic principle. Industrial complexing promotes collaboration among industry to exchange resources, byproduct, and waste stream, aligning with the circular economic principle. Like example is same. You like all three questions were similar question. It has been asked in just different form. Okay, now in a circular economy, resources are reused, recycled, and kept in circulation to minimize the waste and environmental impact. For example, industrial complexity, one industrial waste example, fly ash from the power plant can be used as a raw material for cement production, reducing the need of virgin resource and landfill disposal. Okay, na? So like if cement industry won't be going outside their miss miss anywhere else to get their raw material, or it won't be affecting the natural raw material. It will be just taking the waste material that is produced from the power plant. Okay, now these approaches enhance the sustainability and efficiency, often supported by shared infrastructure like common effluent treatment plant. A resource industrial aims to optimize resource use and reduce not deplete. We know that same raw material being used at two places and all these things. Environmental degradation, no, it is also not correct. None of these. So correct answer was A. Circular economy principle. I hope this is okay to everyone. Question number 4. Which are the following pollutants mainly found in wastewater? This thing we have discussed few minutes ago when I was recapping. D. All of the above. Yes, correct. Main waste originate from surface water, groundwater, and process water in mining operation, and can contain a variety of pollutant depending on the mine type, geology, and activity. Characteristics of mine include acid mine and alkaline mine water, and collectively include organic matter, which like we have seen that COD BOD was very less, but it doesn't mean that there means there is a small amount of organic matter, but it is there. And we know that in our wastewater, in our soil, we have very less amount of organic matter. Okay, na? So you can see that it is ranging between 8 to 6 milligram per liter. Okay, na? Heavy metal, we know that iron, Mn, magnesium, all these minerals are there in our soil, and that will leach out. Okay, so heavy metal is also there. Then in organic matter, we know that a huge amount of inorganic matter, sulfate, chloride, this sorry this iron, magnesium, and these are also inorganic matter only. Okay, now since mine wastewater composes all these pollutants, organic, in very less amount, heavy metals, inorganic matter, all of them accurate when considering the broad scope of mine wastewater characteristics. Question number question number 5. What is the term used to describe the mixture of water and solid particles produced during mining activity? What is the term used to describe the mixture of water and solid particles produced during mining activities? Okay, B. Yes, correct answer is B. So, tailing is the term used to describe the mixture of water, fine solids, and the residual chemical produced during the mining activity. Tailing are generated when ore is processed to extract valuable minerals, leaving behind a slurry of the ground rock, water, and sometimes chemicals used in the process. So, I hope you have like when we know that the raw material for any mineral is called ore. Okay, na. So to extract the any element, say suppose aluminum or anything, first we make slurry and all this thing, and there is another process also that we are not going. But you can see that whatever present in this ore will be dissolving in that water. Okay, na. So it will producing a huge amount of suspended solid. Okay, na, solid particle or suspended solid, simply says suspended. So this process is called tailing. Okay. Mine water interact with the water pipes or tailing, uh, uh, which can contribute to contamination such as in acid mine drainage, which sulfide containing tailing oxidized tailing are typically stored in tailing dams or ponds and are significant source of pollutant like heavy metal and sediment, because a huge mixing has been done. Mine discharge is different thing. Mine discharge refers to the overall wastewater released from the mining operation, including water pumped from the pits, surface runoff, or treated effluent. It is a broader than tailing and not specifically a mixture of water and solid particle from the ore processing. Mine water used to describe discharge distinct from the tailings. Okay. Sedimentation, we also know that sediment. What is sedimentation? Settling and all these things. You notice sometimes it describes the settling of the solid particle. Okay. Question number 6. Which regulatory body is responsible for overseeing the mine water management? Mine wastewater management. A. EPA. Yes, correct. EPA. The Protection Agency is a primary regulatory body responsible for overseeing mine wastewater management in United States. EPA enforces regulation under law like Clean Water Act, which govern the discharge of pollutant into water through national. This is nothing science is here, but you should know what this EPA, how this EPA work, how this for what purpose WHO work, for what purpose IEA work, and UNESCO work. Okay, na. So we will swing this thing. EPA also regulates the mine. EPA, EP, under this thing, and then coming to the other option, what is WHO? The WHO focus on a global public health. This works on health related, so whatever the health news you might have heard, you will be hearing from WHO. Okay, now setting guidelines for drinking water quality, health related, environmental substance, whatever the limit you might have, drinking water limit. So if you have read any research paper, okay, na. So you might have seen two things. Suppose they are talking about fluoride. Okay, na. So you will be seeing that it will be always written as per, suppose if you are reading in India, then it will be written as per WHO and Indian standard code. Okay, na, Indian standard code. IS 10500, the limit is 1.5. And there are some contaminant where WHO limit is different, Indian limit is different. So that will be also written that as per WHO, the drinking water limit for this is for any X contaminant is by X contaminant is 1 or 2, or and as per Indian standard it is different. So there are some contaminant whose limits are different as per WHO and Indian standard. If you refer to any most of the time they will always there will be two mentioning of IS code, one of their own country and one of WHO. Okay now. Then we have something called International Atomic Energy Agency. This promotes the safe and peaceful use of nuclear technology, including regulating radioactive waste from the uranium mining. However, it does not have authority of general mine wastewater, so it deals with nuclear waste such as uranium and all these things. Okay, now then we have United Nation Education, Scientific and Culture, UNESCO. UNESCO focuses on education, science, culture, heritage, preservation, protecting water related and this thing. This is very different. Okay, so the correct answer was EPA. EPA maintain this what do I call mine related wastewater. Huh. What is the primary cause of acid mine drainage? This thing also if you have paid attention to our my recap, yes, correct answer is pyrite, because reaction of this pyrite releases too much of H plus. Presence of pyrite, you can see this reaction, this is pyrite. Okay now, so as it reacts with H plus, it releases Fe2 plus and 4H plus. Okay now, this 4H plus is increasing H plus concentration, and minus log H plus concentration is giving us pH. Okay now, so if this is increasing, overall this is increasing, making it acidic. Okay, pH calculation, we don't have time, but in future if you like next time I might be treating groundwater treatment and all this thing, there I will be focusing on this pH calculation and all this thing. When pyrite is exposed to air and water during mining activity, it undergoes oxidation producing sulfuric acid, ferrous iron and sulfates. The reaction lower the pH, typically 2 to 5, creating acidic condition that dissolve heavy metals like this from surrounding rocks, forming AMD. The key reaction is this thing. Okay now. So see, there are several reaction like for manganese, and they will remain in their mineral form in some mineral oxide, amino oxide or anything. But when pH is lowered around 2, so what happened that they start to dissolve, and they start to dissolve, and similarly they started to come into the water. So it's all dependent all the pH and all this thing. Subsequent reaction, there is another thing which again do we have gone through this thing. Natural water, why other options are incorrect? While bathing can contribute to metal leaching, it is not primary cause of AMD. AMD is significantly driven by the rapid oxidation of pyrite, which we have seen. Volcanic eruption, volcanic activity can release acidic compound, but it is unrelated to mine drainage. AMD is mining a specific issue tied to sulfide mineral, not geological event like eruption. Okay. Marine pollution involve contaminated in ocean and all this thing. It's not related to AMD. So the correct answer was C. That is due to pyrite. Okay. I hope this is clear to all. What role do bacteria play role in play? What role do bacteria play in acid mine drainage? Bacteria neutralizes acid mine water. Bacteria has no effect on mine water quality. Bacteria promotes the growth of aquatic plants. Bacteria oxidize the pyrite to form acid mine drainage. D. Yes, correct answer is D. Bacteria oxidize pyrite to form acid mine drainage. Correct answer. Bacteria, particularly this bacteria and other acidophilic species play a significant role in acid mine drainage by oxidizing pyrite to form acidic condition. Pyrite condition begin chemically when begins pyrite oxidation begins chemically when exposed to air and water, producing ferrous, that is Fe2 plus, uh, uh, su- sulfate and hydrogen H plus, and we have seen this reaction. Okay, now this is pyrite reaction, H plus and H2O, it produces H plus and pH is increasing. Bacteria extracts the rate determining exposure, overturning Fe2 plus, and now what happens is this bacteria will convert this Fe2 plus to Fe3 plus, means it is oxidizing. Okay, now so what happened that this iron 3 which is ferric is there, again it will oxidize this iron 2 which is in plus 2 form. Okay, now so uh, finally this reaction goes in cycle and cycle. Okay, this again we have Fe2 plus, then we have, you can see that here is H plus is also releasing, here H plus is also, pH is increasing too much. Okay, now this bacteria catalyst significantly increases the MD acidity, pH 2 to 5 and metal content, worsening the environmental impact. I hope this is clear. Everyone should be familiar with this reaction of pyrite in mining industry. Okay, any doubt? No. uh, we have seen these are incorrect. It does not neutralize it has some effect. Equity thrives in MD consider, which is toxic to aquatic plant like thyron used to destroy bacteria do not promote, they contribute to the problem being generated, so it does not promote any kind of life and all this thing. Which of the following is not a conventional method for treatment of acid mine drainage? Electrochemical treatment. Other anyone else? And we have got one is aerobic wetland system is also, someone is saying B also. So we have got two answer B and C. First you should know that where is this biological treatment is done, where this electrochemical is done, where aerobic, I mean what condition this should be done, whether those conditions are being maintained for acid mine drainage. If yes, then see, whenever this type of question is being asked, you should go through each and every option, where this precipitation, how this precipitation will remove anything. Okay, so precipitation, like if we add something, will something precipitate? So we know that we have a Fe, we have Mn. So if we add oxygen and all these things, then there is a chances that FeO2, hydrogen hydroxide, iron hydroxide may precipitate. Similarly MnO2 might precipitate. So yes, this is used. Aerobic wetland, wetland, how this wetland, aerobic wetland means in presence of air. So there is a plant and water is fast. So what happened that whatever the mineral is being used, is in our wastewater, it might be getting entrapped in this wetland. So yes, this can be also used. Biological treatment, yes, we know that we have some BOD and COD. So yes, biological treatment is done. Electrochemical treatment is generally done. When is electrochemical treatment? Like there is one single thing and we want to convert into some other form and then can be removed. Like we are providing some electricity, and it will convert into some other form and then it can be taken out. But generally it is done for single entity. Suppose in our water we have only chromium, so there is a chances that we can apply electrochemical, like we can produce like how electrochemical for chromium is done. Generally chromium is present in chromium 6. Okay, now so electricity is provided. So what happens that this chromium 6 will get converted into chromium 3, and again it will by adding some hydroxide, or by adding something, it can be precipitated in the form of chromium hydroxide, chromium 3 hydroxide. Okay, now iron is also added in this case, but this is But in our wastewater we have seen that we have Fe, we have Mn. So where to apply this electricity and all, for to whom to apply this electricity? So this thing is not possible. So that's why this conventional method, Miss C, will be our answer. Electrochemical treatment. Conventional method for treating acid mine focuses on neutralizing acidity, precipitating metals, and removing contaminants using a stable widely take place. Based on this context covered this thing. You can see that this neutralization precipitate involve alkaline agent like limestone. We have seen that limestone, that is limestone, when we will add limestone hydroxide, calcium hydroxide, what will happen that it will raise the pH. It will raise the pH around 10 to 12. So at this pH a huge amount of OH minus will be there, and so what will happen that Fe which is there, Fe will react with OH. It will form FeOH whole twice, and if Fe3 is there, FeOH whole thrice will, and this will precipitate. Okay now. So yes, neutralization and this thing is done. Aerobic wetland system are passive treatment to shallow with the help of plant to oxidize the precipitate metal iron, commonly used for near neutral or acidic, less acidic mine water. So this thing we have seen. We have seen what is wetland and all this thing. So water will be passed through here. Whatever this contaminant will be there, it will be get entrapped in the plant. Biological treatment is correct. Biological treatment, as we have this thing, BOD and COD in our water, we have organic matter in water. So biological treatment like anaerobic wetlands can be used. Okay. Electrochemical, how is not conventional method in advanced like electrocoagulation or electrolysis to treat wastewater, which is less common due to high energy cost, complexity, and limiting application in large scale MD compared to the other method. Why it is limiting? Because in our this we have huge amount of variation, Mn, iron, sulfate, and other things. Okay. So those who were saying B, I hope you have got it. This why B was not our correct answer. Janani. I hope you have got it. Why B was not answer. Aerobic wetlands. Here you can see this is conventional. This is conventional passive treatment effective for AMD with higher pH or after pre-nucleation. Wetland promotes metal oxidation and settling, making them common low maintenance solution. Okay, na. So these are the some of the reason why this is like this. This is used. Okay, na, aerobic wetlands are used for treatment of AMD, but this electrochemical is not used because these are very specific and high costly also. Question number 10. Which of the following is not recovered from activated carbon? Does odor is being removed from activated carbon? Color is being removed. Micro pollutant, micro small quantity pollutants, and none of the above. D. Anyone else with other answer? What about other? Nitya, Nitya, Janani. D. Okay, yes, D is the correct answer. Activated carbon used in wastewater, that is in CETP, are highly effective for removing a variety of contaminants due to their large surface area and absorption properties. Orders activated carbon absorb volatile. See why order we have order in our system in any water and all, due to presence of volatile organic matter. So those volatile organic matter evaporates and is vaporize, and we get the smell of those things. Okay now. And now imagine if you are removing those volatile, so obviously there will be no, what do I call, no odor. Okay now, and other causing molecules effectively reducing unpleasant smell in the wastewater. Color, it remove organic compound and dye that contribute to water. discoloration. Micropollutant activated is efficient at absorbing micropollutants such as pesticides, pharmaceutical, and trace organic matter, which are often present in the industrial effluent. Since activated carbon can remove all these odor, color, and macro, the correct answer is D. None of the above, meaning there is no listed contaminant that is activated that does not remove. So yes, those who were saying uh, D are is correct. Okay. Till now, anyone have any doubt? Anyone have any doubt? No, then now we have rapid questions. Like I won't be explaining in detail. Uh, and So, why does Indian coal sulphurs lead to significant AMD due to issue in some uh, mines? Why does Indian coal lead to significant AMD issue? High as content utilizes acidity. Presence of pyrite and why you were saying A? High ash content neutralizes acidity. I mean, this thing we have discussed currently. AMD, AMD is due to this pyrite and all this thing. Why you are saying A? This thing we have discussed twice about pyrite reaction. There is one more question related to this pyrite. I hope you will answer it correctly next time. AMD is due to like this oxidation, and we have seen that the presence of sulfide, pyrite oxidation, and all this thing lead to significant issue because it raises the pH to very low, around 2 to 5. Okay, so I hope you have got it. The correct answer is the while the Indian coal have low sulfur overall localized pyrite in the seems to undergo oxidation generating. Hmm. This low sulfur percentage is misleading because even a small amount of sulfide mineral can produce significant acidity when exposed to water and air. Got it? Even though a small amount, but this reaction is very this FeH2 in presence of O2 plus H2, even if it is in a small amount, it will produce. See now, this 0.6% is also huge. A small amount of acid can cause many things. Okay, na? So a huge amount of H plus will be released, and that is sufficient to lower the pH, and that is a issue in AMD. Which factor makes the rate determining step in AMD formation particularly challenging to control? We have seen that there were four steps. For reaction we have seen na. Which factor is rate determining? Rapid hydrolysis, and thing is that we cannot control also. We have got B one answer. What about other? Take your time and try to answer it. Which factor makes the rate determining step in AMD formation particularly challenging? And it's like it's very challenging to control it also. C. sulfate production, slow oxidation of ferrous to ferric iron. Okay, let's see the answer. Yes, B, slow oxidation to this thing. Okay, now so I will go the slow this the reaction this is rate determined because it's slow it is slower than the other step and depend upon the oxygen ability and pH. Bacteria like this accelerate making it control difficult. Okay, now so this reaction is individually controlled by bacteria and all these things. There was one question related to this thing now. Where did it go? Huh. See here, you can see that this bacteria is being accelerated. Okay, now, but those who one person says C, that is sulfate control. This sulfate can be controlled. Okay, now how sulfate can production can be controlled? Sulfate production can be controlled by controlling this production of this iron to iron 3 can be precipitated in some forms. It's not written here directly. Hmm. But this Fe3 plus, like, if we somehow remove this Fe3 plus, this production of sulfate can be controlled. Okay, na. So that is not limiting thing. The determining step is this itself, the presence of H plus and this O2. Okay, na. So I hope the one who were saying this uh, mm, C and also not a huge amount of sulfate is being produced, very less amount of sulfate is being produced. Okay, na. The main thing is the presence of oxygen and H plus. Did you get it? Those who were saying C, neage, you were saying C. The sulfate there is two problem with sulfate production can be controlled. That is not a step, because how sulfate production can be controlled by controlling Fe3 plus. Fe3 plus can be easily controlled with some of adding alkaline and all these things. And also high. I hope you have got it. In Jharia coal mine study, what is the primary constraint for meeting water demand? This is related to your lecture notes. If you have gone through the lecture notes, you will be shortage of 22.5 mgd, million gallon per day. See, Jaria total demand is this thing. Okay, na? This domestic plus industrial, but only 61 is creating itna shortfall. This tricky question. You have to test attention to detail. Okay, so this question was directly taken from your PDF. Okay, so yes, the correct answer is this. There is a high demand, but supply is limited, so there is a shortage of 22.50. Why might aerobic wetlands fail to treat highly acidic AMD? Aerobic, we have seen that aerobic wetlands can be used, but for the pH of 2 to 3, it generally fails. Why? Anyone? D. They are too small for acidic water. No, these wetlands are No, wetlands are really big. You should see, the wetland. You can let me search for you how big wetlands are. Mhm. This you can see that this much of hectare around 0.025 meter square. These are really big. One I'm not getting exact thing, but you can see 11, 12 meter, 13 meter is there. Okay, na, so these are really big. Okay, na, the problem is that to remove or to precipitate any metals, they require neutral pH. Okay, na. We rely on oxidation and precipitation of metal like iron, which effectively in alkaline or near neutral conditions. See how they precipitate, they need OH plus. Okay, na, so if iron is there, so this will react, or any metal is, say chromium is there, or Mn is there, so they will react and they will precipitate. If too much H plus is there, then this H plus does not react with anything. Okay, na, this H plus remain as it is. Okay, so that's why a neutral pH, so they require neutral pH, so the correct answer is A. Again requesting everyone, please participate. Which MD treatment method could invariably increase sulfate concentration in treated water? Sulfate. Sulfate, which can increase the sulfate. In we have seen that this reverse osmosis is there, anaerobic wetland is there, then we have limestone neutralization is there, then we have ion exchange is there. Yes, anaerobic wetland reduce the sulfate to hydrogen sulfide, but incomplete reduction or reoxidation or downstream process can increase the sulfate levels. This tricky scenario tests the understanding of microbial process and their limitation. Okay, na? So yes, the correct answer is B, anaerobic wetland. Okay, na? Because oxidation and reduction, first sulfate is getting transferred to hydrogen sulfide, but again due to reoxidation, this again there is an increase in sulfate concentration. Mhm. What makes the yellow white deposition in AMD affected water uh, particularly problematic? Okay, now yellow why ferric oxide. I'm just giving hint. Ferric oxide. Sorry. Yes, ferric oxide means deposition means saying that it is precipitating. As it is precipitating, it will clog something. What it will clog? It will clog the waterways, and so yes, it's clog ferric oxide. Precipitator is solid, clogging the streams, converting and support the aquatic organism. Okay. What is the characteristics of alkaline mine water? Complete it is used for drinking uh, without treatment. Which characteristics? Due to which of the following we have to treat this water? Is it low pH, high hardness, low sulfate contents, or absence of metals? B. High hardness. What is the hardness limit? As per WHO, as per our IS code. What is the permissible limit of pH also? Acceptable limit. There is no permissible limit of what? What is the acceptable limit of pH? Does anyone know? Limits of hardness and limit of pH. First, say about pH. What is the limit of pH? Anyone? Anyone? What is the 6.5 to not 6? Not yes. Is it 6.5 to 8.5 or 7.5? I think it is, yeah, 8.5. This is acceptable limit or permissible limit. This 6.5 to 8.5 is acceptable or permissible? You can unmute yourself. No, incorrect. This is not permissible. This is acceptable. pH does not have any permissible limit. Remember, generally, if you see the IS code, there is acceptable limit and then there is a permissible limit. Permissible limit is in absence of any treatment. If you see the its limit, it will be written as 6.5 to 8.5, and in permissible limit there is a blank thing. So this is very misconception. Okay, na many people say that 6.5 is acceptable and 8.5 is permissible. No, that is also incorrect. There is only acceptable. We will be only accepting water which has a pH range of 6.5 to 8.5. Nothing else. Not more than that. There is no permissible. Permissible limit is for suppose for I also don't remember what is the permissible limit of hardness, but there is some limit of hardness. Okay, now so that this will be hardness. This will be acceptable limit, and if the proper treatment is not done, then we can drink until permissible limit. Okay, na, but there is no such thing for hardness, sorry, pH. So if you are this is very general question generally people ask. And hmm, high hardness, yes, correct answer was B. I don't know why you are saying C. Sulfate, low sulfate content is there, then there is no need for treatment. pH is also within the drinking water limits, although the like it should be 6.5 to 8.5, but more accurate answer is high hardness. Okay, now high hardness in alkaline water due to calcium and magnesium cause scaling and taste tissue, making unsuitable for drinking without uh, this can be a problem, but this is not much big problem. But this option is also incorrect. It should be 6.5 to 8.5. Then definitely the answer would have been B. Low sulfate content. Sulfate should be very low in our water, not high sulfate should be. I think the limit. Let me open the drinking water limit. IS 105. You can see this thing acceptable, required limit or permissible limit. For pH, you can see that it is between 6.5 to 8.5. No relaxation. Similarly, for hardness, you can see H. Total hardness, sir. It will be total hardness. Total hardness. Permissible is 200. Sorry, acceptable is 200. Permissible is 600. Okay, now we will be accepting water having a TDS of this, sorry, hardness of this much, and we will be rejecting water having hardness above 600. When I was appearing for one interview na, so there was one question like suppose every parameter is correct within the drinking water limit, but hardness is little bit high, say thousand milligram per liter as CSO3. So will you drink that water? So can anyone answer? If every parameter is within the permissible limit, but hardness is little bit high, so will you drink that water? Yes or no? All the parameter, no. Yeah, correct answer is no. Even though this hardness is little bit high only, but we won't be drinking. And remember one more thing, there is one misconception that due to drinking hard water we can get kidney stone. So this is also a misconception, okay na. So I don't know the exact answer how this is how hard water does not cause. There is one misconception that as hard water is contains high amount of calcium and our kidney stone is also made of calcium and all these things. But formation of kidney stone depend upon many things. Like there is something called oxalate. If someone is like if you have someone meets with some kidney stone disease, then generally the kidney stone is in the form of calcium oxalate. So alone calcium cannot cause kidney stone. The cause of kidney stone is entirely different. It depends upon the metabolism of one person, does not depend upon how hard water we are drinking. But the main problem of hard water is not also it is said that the main problem with hard water is not of drinking purpose. The main water is that it causes a economical loss. How it causes economical loss? Because the pipe which supply the water containing hard water get this scaling problem and all these thing, okay na. Scaling, yes. The main problem is this scaling. It is it has to do something with drinking water. So so the answer was like the question which was asked na, can you drink the water? So see, the correct answer is no. But if there is no condition like you are not getting any water, then you can drink that water also. It won't cause any much problem. Okay now, scientifically speaking you are correct that we should not drink that water as per IS code or WHO. But if you have no option, then you can drink. There won't be only there will be loss of your. You won't be also there will be economical loss due to soap, shampoo, so, because you won't be getting foam and all these things. So these things are little bit basic things are there. You should know the basic thing. If you know the basic thing, you would be able to answer these questions. Hmm. Coming to the next question, why is cyclic propagation step in considered as a self-sustaining process? This is the fifth time. I want everyone to answer it correctly. Why this is self-sustaining? Self-sustaining means there is no external thing. It automatically start to like it will see pyrite. Again, the reaction will start to occur. So you should, if you for answering this question, you should look at the first reaction and the last reaction, which is common in both reaction. B. Yes, correct. So see, this is the reaction. You can see that Fe2 plus this uh, the reaction Fe2 plus which oxidized back to Fe2 perpetuating the recycling. This self-sustaining make the AMD persistent and trigger to halt. Okay, now so this reaction goes and goes. So a huge amount of Fe2 plus is there, and this again Fe2 plus react with the second reaction, and this will go in cycle. Okay, now so it's hard to correct control. So the correct answer is B. Which passive treatment method is least suitable for high flow AMD treatment? High flow. C. Yes, correct answer. Again, the question like that in aerobic, there is some time for the reaction to happen in presence of oxygen. Okay, na. Aerobic wetland require long retention time and large area, making them less effective for high flow AMD, where the contact time is limited. Open limestone channel handle high flow better, making it okay. So limestone can easily react and all this thing, but similarly for the anaerobic wetlands also, if there is high flow also, it will somehow cope up the things. But aerobic, there is a involvement of oxygen, and this thing may this presence of oxygen is what this presence of oxygen makes the reaction slow. Okay, na. So there is a huge time of retention time is required, so that's why the correct answer is C. What is the hidden challenge in using anoxic limestone drain for AMD treatment? If we are using limestone, anoxic limestone, first of all, what is anoxic limestone? There is one oxic, name itself suggests anoxic. Oxic means in presence of oxygen, anoxic means in absence of oxygen. So, what is the challenge? Okay, I will say the answer. Hardening by iron precipitate reduce efficiency. The iron precipitate can coat the limestone in acid rain, forming an hardening layer that reduce the contact with acid water, lowering the neutralizing capacity. This issue takes the under. Okay. Uh, so like what happened that challenge is due to this iron. What happened that this iron thing which is there. Uh, um this due to presence of, see, my water is here. If we want to add this limestone, then there should be a proper interaction. Okay, na. But due to this iron pipe, yeah, there is a protection layer of iron. What happened that this layer reduce the contact time. Okay, na. The contact with iron is being reduced, so there is no proper interaction. So overall, what is happening that this reaction is not happening between H plus and OH minus. H plus is already in water, OH minus is coming from the limestone. So overall efficiency decreases. So correct answer is B. Hardening by iron precipitate reduces the efficiency. Okay. This iron precipitate is in the form of ferric oxide and all these things. Why might reverse osmosis be less practical for large scale AMD compared to the limestone utilization? Less effective. Reverse osmosis. B got one answer. B. It requires high energy and maintenance. Yes, correct. Reverse osmosis is energy intensive and require frequent membrane maintenance, making it less cost effective for large scale AMD. Okay. So correct answer is B. Which industry wastewater is most likely to complicates CT treatment due to high organic content? Out of these, which has highest organic content? B. Yes, paper and pulp wastewater has high CO2 from the organic compound like dioxin requiring extensive biological treatment. CO2 other industry produces heavy metal organic which is less organic focused, making this like yes, this because this will produce high organic, other are inorganic waste which can be treated easily or with some other means, but treating organic matter requires some other facility. What is the potential drawback of homogenization in CTP equalization tank? Now, like what happened that there is several industry and all are coming to a single CTP. So there will be we know that we have to maintain a flow rate. To maintain the flow rate, we use the equalization tank. Okay, na? So equalization we maintain the equalization tank. So once these water are mixed, what is the main disadvantage of this? It increases the treatment significantly. It may dilute the toxic contaminant. This is good thing, not a drawback. It remove all the suspended all. It is also it prevent biological treatment. It also good thing. So the correct answer is oh, I was also wrong. Potential drawback they are asking. Equalization tank make equivalent homogenized, but this can dilute the trace toxin, becoming harder to detect and oh, this risky used issue test understand. Oh, so this is like a little bit. You have to think. See, cost will be same. Okay, na cost will be same. So, like there is some toxic material coming from say industry A, and it is X say X milligram per liter. Okay, na and it's and as per WHO or as per limit it should be zero. Now imagine that if it is coming to CTP, it will be getting diluted. Okay, now so now it will be very hard to remove it because it has been diluted, and even though it has been diluted, it will have some concentration. Its concentration might be x into 10 to the power minus 3 milligram per liter. Okay, now but now when it has entered into CTP, it will be very hard to remove. So the correct answer will be B. It may dilute toxic contaminants, delaying detection. Did you get it? This 30 number question, yeah. If anyone have any doubt, why might activated carbon filters struggle with heavy metal removal? This activated carbon, we have seen that it can remove odor, color, micro pollutant, but still it faces some problem. What is that problem? Are they designed for organic absorption, increase their metal solubility, require acidic condition, produces excessive sludge? Which of these? C. They require acidic condition. Let's see. They are designed for organic absorption. Okay, now activated carbon filter excels for removing organic. See, we have seen this thing. Okay, now here I have like in this question number 10. Where it is? Question number 10 we have seen specifically. This is specifically color order micropigment. Okay, na you can see this is only organic things are being removed and trash organic contaminant. Only organic this this is not used for inorganic contaminants. Okay, na. So I hope you have got it. Question number 40. So the correct answer is this. This is designed for organic adsorption, not for metal solubility, or it does not. It requires neutral condition only. It does not. This carbon filter will went bad under acidic condition. So the correct answer is A. It is designed for organic absorption. Those who were saying B and C, Blate and yeah, did you get it? Yes. Which AMD treatment method risks generating hazardous H2S? This is a repetition of one question which were oxidation, reoxidation, and all this thing. B. Yes, anaerobic wetland. Anaerobic reduces sulfate to H2S, a toxic under oxygen free condition. Except, okay. In industrial complexing, why might clustering cement and fertilizer industry increase the treatment complexity? Again, this is very simple question. They generate contrasting pollutants. Cement wastewater is alkaline, while fertilizer wastewater is often acidic with high nitrogen. Require tailored treatment in CTP. This contrast compliance harmonization, making it a treat. Okay, now, so what happened that in CTP, one is producing, we know that there will be equalization thing. Okay, now, so one is producing highly acidic, one is producing uh, one is producing see acidic, one is producing alkaline, so making the system overall the treatment unit very complex and all this thing. Okay, what is the limitation of presence of sand filter in CTP? Limitation of pressure sand filter, we know that we have sand filter, rapid sand filter, yeah, slow sand filter. Generally in CTP there is slow sand filter. So what is the limitation? They are in fact ineffective for fine pressure sand filter, reduce BOD CO2 by and remove larger, but struggle with very fine particle which may pass through. Okay, now generally the sand filter is not generally suitable for fine particles. Why might already answer is given. Why might in situ alkaline injection for AMD less effective in abundant mines? It reduces the groundwater. See, we are adding waste. Now we know that in our mine we have this wastewater, acidic wastewater. Now imagine that what if you are adding waste? What if instead of reacting it, so it leaches out to ground? So obviously it will. If it leaches out to ground, then it will contaminate the groundwater. Okay, so acidity can introduce alkaline compound, especially in abundant acid and uncontrolled hydrology. Which factor in AMD decomposition vary most significantly across the global mine types? I don't know. Again, the answer is already written. Which factor? The metal diversity and concentration. Okay, na. So, due to while pH, sulfate, and iron are consistently high in AMD, the types and concentration of metal are widely depending upon the mine. Okay, na. So uh, due to presence of this thing, the concentration and all this composition of AMD vary significantly. What is the potential long term issue of using open limestone channel for AMD treatment? B. They accumulate metal precipitates. Yes, they accumulate metal precipitates, reducing flow. Open limestone channel utilizes AMD but can accumulate metal precipitate over time, clogging channels and reducing water flow. The long-term maintenance is subtle and test that in treatment planning. Okay, so the correct answer is B. I have missed 20 more questions. I will be going like this only. So before proceeding further, does anyone have any doubt? In week 3, yes. They have not still responded it. In week 3, see, okay, I have already mailed them. No, in PPT. Okay. What is the problem in week 3? Page 36. Let me open. My PPT or lecture note PPT? Okay. Just 1 minute. Page number 36. This page. Okay. Example of design of stripping tower. The height of stripping tower flow इतना Henry constant इतना इतना. Determine the height of transfer using following equation HL. So what's the problem here? How area is taken? This A. Yes. So I think they have given you the diameter. Just let me check. I am not remembering it, so I will just tell you. L is this meter की हो रहा है. इतना 0.03.5 by 4 r square. So they must have given you diameter, radius. Yeah. Yes. Mm, assume the following. Just let me check here. They must have said something about the radius. Design a theoretical element. This is another question. इतना any constant इतना significant इतना G/L इतना मीटर स्क्वायर एयर रिक्वायर इतना the determine the height of string required to flow इतना KL value of ammonia is this much. Assuming the packing factor इतना assuming string factor 3 assuming pressure drop इतना let me check. I think I have solved similar type of question here also. Let me check my PPT. Age cross section area of the tower. Now cross section area of the tower. Cross section area of the tower. How to find cross section area of the tower now? अनमोल अपने GYL इतना मीटर क्यूब है ना. I'm not also getting from where this has come radius. Uh, L is this measure, this is flow, this is KL already given 4 pi r square, r you have to get. Let me see this. Height of the flow is इतना. Just wait one. Oh, we will. Actually, today's session is almost complete. Only few questions are left. Let me check. See, right now I'm not. I have to see the notes. Okay, now please share your email ID. If I come out to know how this radius was taken, I will mail it on to you. Yeah, please share your email ID. You can. Okay. Okay, if miss, I will share. Miss, right now I am not able to get it how this radius was taken, but once I will go through the notes, then I will let you know. Okay, na. Sorry for this thing. I am not also getting where they have taken this. So instead of that, I will look into it after some time. Okay, so coming to actually these are very. Um, what is the primary source of mine water in coal mining operation? This is surface and groundwater from mining pits. Then which state had the highest coal production in 2022-2023? Again, this was very easy question. Orissa. Yes, Orissa has registered. What is the key characteristics of Indian coal as compared to from developed countries? Indian coal B, low sulfur and high. Yes, correct. This is correct. What is the typical pH range of acid mine drainage? Acid mine drainage. As it is saying acid, and there is only one option related to acid, and that is between 2 to 5. Okay, now so B the answer. Which bacterium accelerates the oxidation of? This is also which one? Thiobacillus ferro ferrooxidans. This one B1. Okay, now so this is the correct. Which is the primary reaction initiating AMD? Now this is like eighth question. Similar. Initiating, which is the first initiating AMD? Anyone? B. Yes. B the correct answer. What is the common environmental impact of AMD? This decomposition of yellow. Okay, na this yellow is ferric oxide. Okay, so this like happen this clogs our water bodies and all these things. Which of the following is a benefit of treated mine water as per recent initiatives? B. Benefiting itna lakh people in 900. In Ministry of Coal promoted treating mine water for drinking and domestic use, benefiting 18 lakhs people across 900 village. What is the typical sulfate concentration in AMD? Sulfate concentration. Yes. No. 220 to 200. A was the correct answer. These are actually these last questions are very one-liner question. And very. Which is the common treatment used for alkaline mine? Alkaline mine. See, there till now we were seeing at acid thing. Now they are asking about alkaline. Means like pH is greater than 7. D. One is saying D. One is saying C. Let me see. The correct answer is B. Coagulation, fogulation. See, for the pH greater than 7, generally our wastewater is in alkaline condition if you have normal alkaline. So, for that, we generally use this coagulation and flocculation thing. Okay, na? When system goes to this pH range, then we need a special type of treatment like alkaline and all these things. But if the pH is in alkaline itself in alkaline, then this coagulation flocculation is sufficient. It's used to remove suspended solid from the contaminant from alkaline water, followed by clarification and filtration. Which is the passive treatment method effective for alkaline mine water? Passive. Like we have seen, there is a passive, then there is a in situ treatment. Which one is aerobic wetlands? Yes, aerobic wetland with cellophane plant like this one are effective for precipitating air. See why this is effective? because the pH is between, if you have seen the pH range, it's between 7 to 9, and that is suitable for this aerobic wetlands. Okay na, so that's why it is easily able to remove. What is the disadvantage of passive treatment method of, now they are asking what is the disadvantage of that thing. Aerobic, we have seen that aerobic wetlands, but what is the disadvantage? Yes, large land requirement, a huge amount of land is required, and land is very pricey and all these things. Require significant land and slow and produce hazardous sludge, and they may low energy and maintenance need. What is the role of anaerobic wetlands in AMD treatment? Again, they have come to AMD, that is acid mine water drainage. Drainage means water. Okay. Reduce sulfate to hydrogen sulfide. Yes, correct. We have seen oxidation and reoxidation. Which active treatment method use a membrane to treat AMD? Which active treatment method is used as a membrane to treat AMD? They are reverse osmosis. Reverse osmosis is a semi-permeable membrane to remove dissolved metal from salt, offering control and efficient treatment. What is the primary purpose of CETP? Reduce the treatment cost, because many industry will be there, and for all a common treatment will be there, so it will reduce the treatment. What, which industry is associated with high COD in wastewater? High COD means high organic. High organic. This B, paper and pulp. Yes. What is the function of equalization tank in CETP? Equalization tank. Water is coming from A, B, C, D. What is its purpose? B, humanizing effluent by mixing. Yes, correct. Which tertiary treatment reduced BOD COD by 10 to 15% in CTP? Biological treat. Which of the following is biological? Not biological, but it remove BOD and COD by trapping organic matter. Activated, yes. Activated carbon filter. Contaminant reducing BOD COD by 10, removing color and odor in tertiary treatment. What is the key objective of industrial complexing? Increase individual profit, share the resources to reduce environmental impact, eliminate the wastewater treatment. B is the correct answer. Share the resource to reduce the environmental effect. And the last question of the day, Baba. Oh, sorry. Last question of the day, and last question of this session also, of industrial wastewater. Very easy question. Yes, this thing we have discussed. B. So last this question were very easy. So that was all for this uh, industrial wastewater problem solving session. So with this, I think we will end the session. What do I want? What do I want? What do I want? Hmm. I want a screenshot so that I can post on LinkedIn. Huh. If you want, you can open your camera. I will be taking a screenshot and I will be posting on LinkedIn. So if you want, you can open your camera. Okay. What about other two-person? You can show your face here and let me how to just one. Wait a minute. Unpin myself. I don't know. I'm not able to do that setting. Just wait for 1 minute. I will take only few minutes. Okay, your Nitya, your camera is tilted. You, huh? Okay, so everyone see here. I'm taking one screenshot. I hope I have taken the screenshot. Okay. I am sharing. If you want to follow me on LinkedIn, you can follow me. I'm sharing my LinkedIn profile in chat box. It was nice meeting you all. Next year I will be also miss. I don't know which session I will miss, which topic I will be given, but it will be related to environment only. Okay, so if we are lucky enough, then we can meet again. Or this is my LinkedIn profile. If anyone want to contact me in future, you are always welcome. I will be very happy to help you all. Okay, now, so this is my LinkedIn profile. I hope everyone is on LinkedIn. I request, miss, I insist everyone to make a LinkedIn profile. LinkedIn's are really good. Okay, so maybe I will be posting by today or tomorrow, so you can see the post also. And if anyone have any doubt, they can ask. If anyone have any doubt, you can ask now, or else all the best for your exam if you have registered for your final exam, and all the best for your future.
Thank you, sir.
Thank you. It was really nice. There are this Blete Neage. I think you were always there throughout my session. So thank a special thank you for to all. Then this Janani also, he was see, I don't know, see he see see, you were also there for throughout the session from week 1 to week 12. So a special thank you to everyone. And I think everyone has my email ID and my LinkedIn profile, so you can always contact me. Okay, now for any research related or any educational related advice, yeah, help, I will be happy to help. I am always available on LinkedIn, on available on email. I always keep checking my email and all these things. So if you have any kind of doubt, you can always write. Okay, my email ID is this thing. You can always write to me. I will reply you. This is my email ID. This is my email ID. I have already given you the LinkedIn profile. You can follow me back, or you can text me there also. I will be just okay. So if there is no doubt, and then I think I will be ending the session here. Okay. So does anyone want to say anything, or should I end the meeting? Nice time to. Okay. Thank you. Okay. All the best to everyone. Keep doing your best and be happy. Tata.
Bye bye. Multiple questions will be there, yeah? More?
Sorry,
Multiple questions? Just like what we have did now?
I'm not getting what you are saying.
Theoretical question will appear in the exam.
Yes, there will be theoretical question in the exam.
Theoretical questions more, yeah.
No, most of majority of the question will be theoretical question in your examination, because
Oh,
this subject is more focused on theoretical thing.
good. Okay, okay, sir.
Okay,
Okay,
but I
okay.
will suggest, see, very limited numerical questions are there, so I will request you to practice all those numerical questions, because only those you will be seeing that whatever example questions are there in lecture notes has been given to you. So,
Okay,
and theoretical question will be also similar to what has been discussed in problem solving session or assignment problem.
okay, okay, sir. Thank you very much. Nice time to you.
Okay, okay, okay. So I am ending the session for the last time. All the best for your future endeavors. Tata.
Bye, sir. Thank you.